In the normal transmission of pain, ascending nociceptive signals travel up the spinal thalamic pathway to the thalamus, where they are processed and relayed to cortical and other areas. The ascending pathway also relays to the periaqueductal gray matter, an important part of the descending pain modulating system, where specific cannabinoid receptors are located. Stimulation of the periaqueductal gray is known to produce an analgesic effect. However, this neuroregulatory process is thought to be tonically restricted by inhibitory GABAergic off cells. Ascending pain signals relayed through the periaqueductal gray suppress the activity of GABAergic off cells through cannabinoid modulation, thereby increasing activity in the descending pain modulation pathway and increasing the analgesic effect. This is called depolarization-induced suppression of inhibition. A synaptic feedback mechanism is believed to be an inherent part of our normal neuroregulatory processes, including descending pain modulation. In many regions of the CNS, including the periaqueductal gray, the generation of postsynaptic action potentials is modified by an endogenous cannabinoid regulatory system. Endogenous cannabinoids are synthesized on demand from the phospholipid bilayer of the postsynaptic membrane. These lipophilic ligands are released directly into the synaptic cleft and act in retrograde fashion on the presynaptic neuron where the cannabinoid receptors are expressed. Binding of the endogenous cannabinoids affects intracellular signal transduction pathways, reducing the influx of calcium ions into the presynaptic neuron, causing a decrease in further neurotransmitter release. This in turn influences the frequency of postsynaptic firing. The administration of exogenous cannabinoids orally or through inhalation may therefore provide an option for treating pain that has responded poorly to conventional pain therapy. When exogenous cannabinoids are administered orally, they travel via the GI tract to the liver, where they are metabolized before entering the bloodstream and then the CNS. The onset of action from oral administration is less rapid compared to the inhaled route. When exogenous cannabinoids are inhaled, they travel through the respiratory tract to the alveoli of the lung, where they diffuse rapidly into the circulatory system. They then travel through the bloodstream towards the CNS, where they diffuse across the blood-brain barrier and into the surrounding tissues of the brain and spinal cord. Exogenous cannabinoids exert their modulatory effects upon the abundant cannabinoid receptors distributed throughout the CNS. The effects of cannabinoids may be illustrated by comparing three neuronal synapses showing normal pain transmission, the influence of endogenous cannabinoids, and the influence of exogenous cannabinoids on the synaptic neuron, and mimic the endogenous synaptic modulatory effect by decreasing influx of calcium ions. In this way, pain and other neural processes are modulated. The clinical effects of exogenous cannabinoid administration are not limited to pain and have proven effects including the reduction of anxiety, spasticity, anorexia, and nausea. The development of novel drugs to modulate endogenous cannabinoid reuptake and metabolism may also prove beneficial in pain therapy. The therapeutic benefits of cannabinoids, including modification of the endogenous cannabinoid signaling system, should be further explored through clinical research.